Hey guys, welcome back to Chris V's RF Designs. So in this video I want to show you my improvement in the design process of part 1 in the RFIC design from my last video. So as you can see, I have created multiple circuits of the same thing. Here is a low noise amplifier and the mixer here, and I also down here I put two of the same low noise amplifiers back to back, which will actually create enough gain to be able to maybe get a better result for my IF output of 100 megahertz, because it may not have enough signal coming through, and it wouldn't be enough to get to the output probably. So I need to, I get enough gain into my mixer here. But usually the thing that's going to power the mixer is actually the oscillator. I will be using a signal generator for it later on, but anyway, and then also here is the same low noise amplifier right here, and also down here there's a couple of other circuits. They're new ones, new low noise amplifiers at the same frequency. I just wanted to test them because I used my software to figure out what the source reflection coefficients would be, and therefore I needed to, so that I could get a way to know what stub matches I need for my matching circuits for the input and the output of the low noise amplifiers here. So maybe I might actually have a better gain of 2.4 gigahertz here instead, but we'll see. I need to get this manufactured and get it tested. So I have a lot to do here. As you can see, the first circuit here is the same circuit from the last video. And also one extra thing before I keep going from my last video, I said the dimensions are in this video right here, but I am wrong. It is not in here. It will not show the dimensions. It just shows you how going from PCB layout to just basically manufacturing, getting the thing manufactured, getting the Gerber files and all the files out to them. It doesn't show any dimensions on it. It's not. And I created as I said, two new LNAs here. You can also see the dimensions of everything else in USIMIX. And I want to be able to show them to you here. Make sure that you can see them, see everything that I have for all the transmission, for all the marker strip lines, and the stub matches here. And also so did I show you these? The dimensions up here for all the marker strip lines there also, and the values for all of the capacitor values and inductance values for the IF output here. Alright, and now let's go to, so I actually got an extra month for free on Advanced Design System, and I wanted to be sure of the results that I have and see if, make sure that, that it is correct. Here, let's see here. So these first two, I did something wrong. I think I had a bad STP file for this circuit here. So these are all low noise amplifiers. This is the original one, the first one. As you can see, these are the dimensions and the values for the resistor, the stability resistors that I used from my original low noise amplifier that I created last time. And then I decided to double that same low noise amplifier up, and as you can see, I did that here. This is just connecting the two low noise amplifiers with an extra line there. Just made it as small as I could. 6.45 millimeters between two of the low noise amplifiers there. And down here I designed the 2.4 gigahertz, another 2.4 gigahertz low noise amplifier, and I used my software this says long line, short line stub length 0.5 centimeters. I just want to basically show you the sizes here for everything, because throughout this whole video I want to be able that throughout this channel I want to be able to have everything shown, because last time, since I've been designing, I designed the 3 gigahertz low noise amplifier, but I really wanted to get a 2.4 gigahertz low noise amplifier going instead. So I mean, I could have done a 3 gigahertz also, but it doesn't really matter to me. All I want to know is how to design it at a specific frequency, and just learn how to design a radio frequency integrated circuit design. So, and here's the same circuit here, but all I did was just double it up down here. And I used my software to get the reflection coefficients, the source reflection coefficient, and the and the load reflection coefficient. So that I can calculate the input and output impedances to create a matching circuit for the stub matches here. So let me simulate it and show you the results that I got. My computer's a little slow today, so hopefully this will go through a little bit quicker. Alright, here are all the results here. So these are the first two circuits, which I had the wrong S2P file. This is the original one right here, I believe, M5. Let's see here. So this is the original one right here. So I'm using G5 terminal and 6. So 5 and 6. Hold on here. Oh, this is it. 5 and 6. This is the original one. The original low noise amplifier that I created last time. And here I doubled it. I doubled them, I put them back to back and have a larger gain. Here's the results. So 8.7 is kind of like S21 instead. And then here is the so 10 and 9. This is, oh yeah, that's the doubled one. 10 and 9. Yep, this is the one that I used my software to figure out what the reflection coefficients are, where the source reflection coefficient would be for the low noise amplifier. And this is what I got for the results. And I got larger gains here. I'm just curious to see if it would actually work well this way, instead of having to use the layout, because last time I used the layout and it was a lot of work to do. But I want to just check to see if, you know, maybe I could get a better gain or better result maybe through it. Alright, so let's go back to Eagle here. There's one improvement that I've done from my last videos. The first thing is that the voltage regulator from my first low noise amplifier was not working, and that was because the voltage regulator was not connected correctly. So now I went to the schematic here to see where the output of what pins I needed for the output and the input here for the voltage. This would the input voltage, it would be 9 volts coming in, and then an output of 5 volts at the output. So as you can see, there's an R1 and R2 here. I figured out, you know, so to get 5 volts, let's see what I used here. So as you can see here, so I placed, so this is where the resistors will go here. This is the voltage divider here, and I'm going to put a variable resistor in and vary the voltage, the bias point, so I could actually vary the if I vary it, I could actually change the frequency of the low noise amplifier actually. But on the first test that I'm going to do, I'm going to put this all the way to as max as it can go, so that I can get 5 volts exactly, as I did from my last videos. I had 5 volts output, and that's what I want to do next time I test it. But then I may also try to vary this and see if I can also change the frequency of the low noise amplifier also. So as you can see here, I got C4 for the capacitor also here. And then the other thing is that this stub, I changed it because I accidentally had different substrate sizes for the low noise amplifier and mixer. So I changed the size of the substrate for the mixer to a height of 0.6 millimeters, which is the same as the low noise amplifier substrate size. So in my last video I had a different substrate size, and it wouldn't be the same size as the board for the low noise amplifier. But we want to make sure that our board is going to be all the same size, you know. We could make the board a different size on one end and then one on a different, but I'm pretty sure that wouldn't be very doable for a manufacturer to do, you know. So And so since that changed, since I changed the substrate sizes, that resulted in a different stub match for going from the low noise amplifier to the mixer, as you can see here. So the last video I had a longer line stub here, but now it's shorter because the substrate changed. Alright, and the best way to match, I found, when I matched the circuits, was I used a tuner instead. It is good to understand how to find the input impedance, but I've noticed that in Usimix I'm getting a better result here for my 100 megahertz output this way. So that's why I changed. I used this tuner here to tune the sizes of the microstrip lines, and I got a better result here, and that is what I did. So I want to use that for it, and that's basically it, guys. If you like the video and would like to know more or ask questions, you can ask questions on here in the comments, or give a like, subscribe, and if you'd like, you can give donations. I will have my account shown on in the description below. So, and the next thing, the next thing that I will be working on is designing the oscillator, which I am right now trying to learn how to get a 2.3 gigahertz oscillator design, and that will be coming up soon after this video. And thanks for watching, guys, and hope you liked the video. Please subscribe, and thanks for watching. Have a good one. Bye.